So our question is the de Broglie wavelength of an electron in the fourth Watt orbit is, and these are the options. So as we know, de Broglie wavelength is denoted by lambda. So we have lambda is equal to h by p. This is our first equation. According to Bohr's quantization condition, we have mvr equals nh by 2 pi. Here n is the nth orbit, so here this becomes, as we know, mv equals p, so p r equals nh by 2 pi. This is our equation number 2. So from equation 1 and 2 we get lambda equals h into 2 pi rn by nh. It becomes lambda equals 2 pi rn by n. So we have to find for the fourth orbit. So in order to find for the fourth orbit, our n equals 4. So we will write n equals 4. Here lambda equals 2 pi r 4. We are replacing n with 4. This is our third equation. So as we know, r is directly proportional to n square, the orbits. So here r1, r4 are the first orbit and the fourth orbit. So here r1 is 1 square upon 4 square. So this is r for orbit 4. So this is 16r. So now we have to just substitute this value in equation number 3, which we have here, and we'll get lambda equals 2 pi 16r by 4, and after solving this we get 2 pi r 8 pi r 1, and here is our answer. So as you can see, 8 pi r, and here's our option C, 8 pi a naught. They both are the same. So there we go.